Okay, end behavior. This is what a graph looks like, obviously. This is x positive infinity. This is x negative infinity out that way. So as x goes to positive infinity, what happens to our graph in this first one? Y equals negative 2x to the fourth power plus 3x to the third power minus 4x to the second power plus 6x minus 1. Okay, so as x approaches to positive infinity, what happens to y? What happens to the function? Okay, so the leading coefficient here is negative 2. So the leading coefficient, so that means you got negative infinity. Okay, the other side is determined by our degree, 4. Now 4 is even, but that doesn't determine whether it's positive or negative, okay? Even means the end behaviors have to match. So if we have negative, we keep it at negative infinity. Okay, number 2, y equals 3x to the third power plus 4x to the second power minus 5x minus 7. Okay, so the leading coefficient, okay, is 3 positive, so it'd be positive infinity. And then our degree is a third power, which is odd, so that means the end behaviors have to be the opposite. Even's a match, odd is opposite. Okay. Next one, y equals 4x to the fourth power minus 3x to the third power plus 2x to the second power minus 7x plus 7. Okay, 4, so that's positive, so positive infinity. And the degree is also a fourth power, because of that. That's even, so again, even means we have to have a match with the end behaviors. Matching, so positive infinity. Okay. Next page. Write a polynomial function given the roots. Only real rational values can appear in the final equation. So y equals, there's the function. None of these have an opposite partner because there's no i's, there's no radicals. So it's just x plus 3, x plus 4, and x minus 10. Okay. There it is. Okay, 5i and the square root of 6. Remember, i's come in pairs. Okay, so so I'd have negative 5i, and then a radical 6, we would have the opposite partner. X plus 5i, x minus 5i, then x plus the square root of 6, and x minus the square root of 6. Okay, so we find these products here and here. Okay, so x times x, and then we have to take 5i times negative 5i. You skip the inner two products because they just cancel. See, that's x times x, that's x times negative 5i. 5i times x, they just cancel, and I just take positive 5i times negative 5i. So x times x is x to the second. 5 times negative 5 is negative 25, I to the second. But I to the second holds that special value of negative 1, which gives us positive 25. So it's x squared plus 25. Okay, then here, remember those are again conjugates, meaning the second term is just the sign is changed on the second term. So that means I know the middle two drop out, x times x, and then square root of 6 times negative square root of 6. Positive times a negative is a negative, and then a square root, 6 times 6 is 36. So the square root of 36 is 6. So it's x squared negative 6, so it's x second minus 6. Okay, then I have negative 4, I've got 2i, and the square root of 10. Okay, so remember, the i's come in pairs, opposite pairs, and the radicals also come in opposite pairs, negative radical 10. The 4 does not have its own. So y equals x minus, but it would go to plus 4, x plus 2i, x minus 2i, and x plus the square root of 10, and x minus the square root of 10. Okay? So the x minus 4 just flies solo. But these have to be consolidated, so do these. Okay? So x times x, and then 2i times negative 2i. So that's x to the second. A positive times a negative 2 is negative 4i to the second. I to the second is negative 1. Okay? So we have negative 4 times negative 1, which is 4. So that would be x squared plus 4. Then x times x, and then the square root of 10 times the negative square root of 10. So x second, positive times negative is a negative. And 10 times 10 is 100, but if you look on the board, the square root of 100 is equivalent to the whole number 10. So x squared minus 10. Okay. Next. Find all roots in the equation by factoring. 5x to the third minus 8x to the second minus 4x equals 0. So there are 3 roots because we have x to the third power. Now not only do we have an x to the third, we have an x second, we have an x, and we have a constant. Or no, we do not have a constant, my bad. 0 does not count, so that's 3. So it's a trinomial. So GCF and the trinomial T-chart. Okay, you got x. Okay, you don't have a negative. 5, 8, and 4 is 1, so 1x. Okay, so I go up and divide by 1x. So if I divide by 1 is 5. X third, x first would be x second. Minus 8, x second, x first would be x. Then minus 4. Okay. So I ABC that, cross out the 1x because I've already placed that within the factorization. 5 times negative 4 is negative 20. So I'm thinking we got to find a positive times a negative, and it's got to add to negative 8. Okay. So 1 and 20. Nope. Divide by 2, you get 10. Okay. All right, 2 plus negative 10 is negative 8. There you go. Okay. Now your A, I'm going to make my 4 parentheses at the start. Okay. And then we know we got a plus 2 and a minus 10. Now how about that 5x squared? Well, we need to place the 5 in each one, and then we break down the x into x times x. Okay, 5 and 2 cannot be reduced. That's only in the first row, so 5x plus 2. 5 and 10 are in row 5, so we divide by 5, and that's going to be 1x minus 2. Now take those over there and check them for dots. Even if you are 99% sure you can. You know the plus can't. And then the minus, I take the 1 off. It's just x, so it can't be done there either. So x minus 2. So we've rewritten that in factor form. Now we apply our zero product property. So x to the first, that's 1 answer, 1 answer, and 1 answer. So 1x could equal 0. X would equal 0 there. 5x plus 2 could equal 0. Minus 2 minus 2, you get negative 2. So it'd be negative 2/5. And then x minus 2 could equal 0. Then I get 2. Okay, those are 3 roots. Okay, number 8, x to the 4th power plus x to the 2nd power minus 20 equals 0. Okay, so there are 4 roots. So we have an x to the 4th, an x to the 2nd, and then a constant. Okay, so that's 3 terms. GCF table. Okay, GCF, okay. No negative, okay. No x, 1, 1, and 20 is just 1, so I'm not going to put anything there. Okay, 1 times negative 20 is negative 20, so it's a positive times a negative. It's got to add to positive 1. 1 and 20, that's negative 19. 20 divided by 2 is 10. Nope. 20 divided by 3 is a decimal. 20 divided by 4 is 5. Okay, that adds to negative 1. We got to make it add to positive 1. Okay, so I go plus 5 minus 4. Okay, now a equals 1x to the 4th. Okay, so you know you got the minus 4 and the plus 5. The 1 can be dropped. You don't need to lead, but this still has to be broken into x squared times x squared. Now, if that were like a 4, you would put 4x squared, and reduce, but that can't be reduced. So you have x squared minus 4, x squared plus 5. Now, the plus we know can't be done. Okay, that just remains. But the minus, you got x times x, 2 times 2. X2, x2, so the plus we drop down. And the minus, we really can't do anything with that either. Okay, so I get 2 roots from there because it's still x to the second, and then 1 from each of these. So x to the second plus 5 equals 0. Remember, we're getting 2 answers here. So that's negative 5. Square root, you got to poke your eye out, okay? So I don't know about you guys, but I don't think 5 really breaks down as a square root. So I just keep that a positive negative I square root 5. And x plus 2 could equal 0. So it would be negative 2. And x minus 2 could equal 0, and in that instance we'd have positive 2. Okay, there's your 4 roots. Okay, number 9, x to the 3rd power minus 4x to the 2nd power minus 9x plus 36. So there are 3 roots. And we've got x to the 3rd. We have x to the 2nd, we have x, and we got the constant, so we have 4 terms now. Use grouping, okay, so grouping, so parentheses plus parentheses, then the GCF lines outside there, then little parentheses, big parentheses. So you have 1x to the 3rd, minus 4x to the 2nd. Then we have negative 9x plus 36. So on your GCFs, you do an x variable check. X squared, negative 1 and 4 is 1. No x, there is a negative. 9 and 36 is 9. Okay. So you divide by 1x second. And here you divide by negative 9. So that's going to be 1x minus 4. 1x minus 4. So you got 1x minus 4 in each parentheses. Okay. So you have 1x to the 2nd minus 9. Okay, bring those over here. Just put x minus 4 and x to the 2nd minus 9. You don't need those ones. This might be a minus, but the x isn't a perfect square. Okay, it has to have an even power to be a perfect square. This has a minus, and that'd be x times x, and 9 would be 3 times 3. Plus, drop it. Minus, but it's not perfect squares. Okay, so 1, 1, and 1. Okay. So we plus 4, that's 4. Minus 3, we get negative 3. And x minus 3 equals 0. You just set them all equal to 0, and that's 3. Okay. Refer to the solutions for problem number 8. Now, it's go back to number 8. Instead of equals 0, it's equal to y, so it'd be a roller coaster graph if I made you do an input-output table. Don't draw this, but to graph it, you basically have to just pick 3 through negative 3, plug them in, and then the graph forms a roller coaster. But that's not what we're doing, okay? The roots are where we set it equal to 0. What did we get? Okay. I square root of 5, negative I square root of 5, negative 2, and 2. Okay. Now your x-intercept is the same as a roots, it's just without the i's. It's just anything without the i's. Now if none of them had i's, I'd just bring them all over, but they do. Okay. In the y-intercept, we simply set the x to 0, but that goes, because it's just 0, and y equals negative 20. Okay, find the quotient, the dividend, x to the third plus 3x to the second minus 1x minus 3 divided by the expression x minus 1. Okay, so we take that x minus 1. First off, set up your dividend. 1, 3, negative 1, negative 3. Now take your dividend, your divisor I should say, and it's equal to 1. Okay, so 1's a divisor. 1 times 1 is 1. 3 plus 1 is 4. 4 times 1 is 4. Negative 1 plus 4 is 3. 3 times 1 is 3. Now you get a remainder of 0, and that's hunky-dory, but you don't solve it. You put 1x second plus 4x plus 3, and that's it. That's all I need. I don't need you solving it. Okay, number 12, x to the third power minus 7x to the second power minus 7x plus 20 divided by x plus 4. Okay. So you're going to have 1, negative 7, positive 20. So you take your x plus 4, set that equal to 0. Okay, so you get negative 4. Pull down your 1. 1 times negative 4 is negative 4. And you add there, it's negative 11 times negative 4 is 44. I add there and I get 37. And then 37 times negative 4 is negative 148. That's obviously not a remainder of 0. It's a remainder of negative 128. Well, that's fine. I don't have to solve it. So it's 1x second minus 11x plus 37 plus the remainder negative 128 over x plus 4. Okay. Okay, next problem. Use the rational roots theorem to find the equation solutions. Okay, now you're finding the solutions. You are solving now. Solutions means solve. So there are 3 solutions, and that's true. We got x third, we got x second, we have x, we have the constant, but you don't want to go right to factoring. Okay, you're going to find the last 2 answers by factoring, but you're going to find the first one using the Rrt method. So I write Rrt and then set up my L. Rrt is a short list, your constant and your leading coefficient. This lines up on top, the leading coefficient. It's factors of constant over factors of the leading coefficient. So 6, 1, 6, 2, 3, and then you're just a 3. Okay, and then 1. So divide them all by 1. 1 divided by 1 is 1. 6 divided by 1 is 6, 2, and 3. Could be positive or negative with all of them. Okay, plug them in. Oh, I got 0 with 1. Okay, so 1, and now I have my divisor. So I've got 1, 4, 1, negative 6. So you pull down your 1. 1 times 1 is 1. 4 plus 1 is 5. 5 times 1 is 5. 1 plus 5 is 6. 6 times 1 is 6. And you got your remainder to 0. So it was 1x third, now it's 1x to the second. Plus 5x plus 6 equals 0. Okay, now you got an x squared, an x, and a constant. 3 terms, factor. No x, no negative, and just be 1. Okay, so I'm not going to put a 1 there. 1 times 6 is 6, positive. It's got to add to get positive 5. Okay, positive, positive. So 1 and 6, no. Divide by 2, you get 3, bingo. Right on the money. So I set up my parentheses, plus 2, plus 3. Now what goes in front? Well, you take your a. If you have 1, you ditch it. If you have like a 4, you put 4, 4. X squared is x times x. And those don't reduce. Okay. And I don't even know why I'm putting these here. They're obviously not differences. So it'd be x plus 2, x plus 3 equals 0. 1 come from each one, which has how many we need. So you get negative 2, and x plus 3 equals 0. You get negative 3. Okay, use properties of exponents to simplify the expression. Now, if we're simplifying, we want to know what our operation is. So we got a times, then a power, a times, power, power. So it's all timesing with powers. Okay, that gives me the go-ahead for the 3 lines. So you got 5 times x times 6. Now, if we run across x again, we just put a plus sign. Okay, 5 to the 1, but it's in parentheses, so 1 times 3 is 3. Now we know there's 2 x factors, okay? That's cool. So we take 2 times 3, that's 6, and then 3 times 2 is 6. 6 plus 6 then makes a 12th power. Then 6, 1 times 2 is 2. All of these are positive exponents. They all stay in their position. 5 to the 3rd times x to the 12th times 6 to the 2nd. Okay, now the 5 to the 3rd and these two get simplified. Okay, so 5 to the 3rd and 6 to the 2nd. Okay, so that's 125 and that's 36. So I put 125 times 36 and always put your variable last. Now I can times till I run into the x. So I take 125 times 36, 4,500. Okay, next, same idea. Times, and then a power, times, then a power, power. Okay, so you have 9 times x times y. So 9 to the 1, 1 times negative 3 is negative 3. 2 times negative 3, I believe that's negative 6. It's going to be 18. Okay, now, these need to switch positions. That one don't, but these ones do. So 9 third and x to the 6th. You switch them so they can become positive. Y to the 18th. Okay, on top, you can't simplify. On bottom, you can simplify 9 to the 3rd. 9 times 9 times 9 is 729. Then x to the 6th. Can't multiply anything on bottom. That's done. Okay, number 16. We got 30 times x to the 7th times y to the 2nd. then 5 times x to the 4th times y to the 6th. So it's all times, you just have 2 out above, below. So 30 times x times y on top. So we'd have a 1, a 7, and a 2. Then on bottom we have 5 times x times y. It's a 1, so it'd be 1, 4, and 6. No multiplying because there's no parentheses. Now you try to cancel. Okay, you don't have a 5 on top, you have an x on top. Get rid of the smaller one. And 7 minus 4 is 3. Okay, get rid of the 2. 6 minus 2 is 4. Okay, so all of these exponents are positives. Okay, they're positive on top, so they stay in position, and they're positive on bottom. They stay in position. Okay, now we can simplify 30 to the first. That'd be 30 times the x to the 3rd, then 5 times y to the 4th. Now, I would not mark you off if you just circled that. Now, if you have 30 over 5, if those have a GCF, which they do of 5, you divide them by 5 each one, and that would be 6 over 1. Okay, so it'd be 6 times x to the 3rd, and then 1 times y to the 4th. You could just put y to the 4th. But if you don't go there, and you put a 1 or whatever, that's fine. Okay, go to and then the last problem. One of the costs to print novels can be modeled by the equation c equals x to the 3rd, there's no negative there today, minus 10x to the 2nd plus 28x, where x is a number of novels produced in the thousands. The company produces 5,000 novels at a cost of $15,000. What other numbers of novels produce the same profit? So when they give me the equation, I write it, put a 1 there. Coefficient of 1, because you're going to need it, trust me. And now I just define what my variables mean. So C is the cost, it's money. X is what we're producing, which is novels. Now they're both in the thousands. So they give me a coordinate, 5 and 15. They're in the same sentence, they form a coordinate. So 5 for novels, 15 for money. So 15 goes in for C. And all the x's turn into 5s. Okay, then I plug that in. What do you know, it's 15. So that works, but now I got to find other x's that can help give me 15. Okay, so we have x to the 3rd power, so that's 3 roots. And I already have one of the roots. I just had 5 in a second ago to give me 15. Now to find the other 2, we need to clear out the 15. You can't forget to clear your 15. Okay, so there you have it. Now you set, don't worry, don't try to factor it, okay? You factor the last 2, but since we already have it, let's synthetically divide by 5. So 1, negative 10, 28, negative 15. So 1 times 5 is 5. Negative 10 plus 5 is negative 5. Negative 5 times 5 is negative 25. 3 times 5 is 15. And that gives me the remainder of 0. So I go off this side. Now instead of 1x third, it's 1x to the 2nd. Minus 5x plus 3 equals 0. So now, x squared, x constant, that'd be GCF table. Okay, GCF's not looking good. Don't have an x, don't have a negative. 1, 5, and 3 is 1. Okay. Okay, 1 times 3 is 3, positive. So we're adding to get to negative 5. So it'd be a negative, negative. They got to match signs when we got a positive, either plus, plus, minus, minus. Since they have to add to negative, probably negative. That's close, but it's not on the money, okay? And then that's the only factors of 3 that exist, because 3 divided by 2 is a decimal. And then if I get to 3, I'm just back to, I'm spinning my wheels because I've already got 3. So QF, opposite of B plus or minus the square root, B squared minus 4AC, B squared minus 4AC over 2A over 2A. So the opposite of negative 5 is 5. And then B got negative 5, 4, and then A is 1, and C is 3. Then A on the bottom is 1. So you have 5, 2 times 1 is 2. Punch that square root into your calculator. Second square root, double your parentheses. You can't use that first one, okay? That's not how it works. Cha-ching, 3.61. Then I just proceed. Okay. 5 plus 3.61 equals, divided by 2, 4.31. That'd be 4,310 if we're by thousands. 5 minus 3.61 divided by 2, 0.70. That'd be 700,000. Okay. You put K because it's in thousand, and then it's novels.